Boom. All right, so this paper is another one by Leonardi. This time he's the first author. So this one is called Akt-Fas to Quell Aberrant T-cell Differentiation and Apoptosis in COVID-19. This is a 2020 paper, so right around the first year of COVID. The end of the first year of COVID, published December 2020. So aberrant T-cell differentiation and lymphopenia are hallmarks of severe COVID-19 disease. Since T-cells must race to cull infected cells, they are quick to differentiate and achieve cytotoxic function. With this responsiveness comes hastened apoptosis due to a coupled, why is that there? Maybe it's stuck. Yep, it was just stuck. With this responsiveness comes hastened apoptosis due to a coupled mechanism of death and differentiation in both CD4 and CD8 lymphocytes via CD95 Fas serin threonine kinase, AKT. I'm gonna highlight that. Boop. And save it. All right, so T-cell lymphopenia is, let's just look up what lymphopenia means. Lymphopenia is a disorder in which your blood doesn't have enough white blood cells called lymphocytes. Okay. AIDS is a chronic immune system disease caused by human emission. So that's something that can happen with AIDS. T-cell lymphopenia in severe cases may represent cell death or peripheral migration. So this could be a result of cell death or peripheral migration. These facets depict COVID as a lymphomanipulative pathogen. Ooh, that's fun. That's new to me too, so let's make that a blue. Lymphomanipulative pathogen. It distorts T-cell function numbers in death and creates a dysfunctional immune response. So we already kind of knew that, so that's green. And then whether preservation of T-cells prevents prevention of their aberrant differentiation. Whether prevention of T-cells, prevention of the aberrant differentiation, and expansion of their population may alter disease course is unknown. Its investigation requires experimental interrogation of the linked differentiation between and death pathway by agents known to uncouple T-cell proliferation and differentiation in both CD4 and CD8 T-cells. I'm really excited to drink my tea. I got some throat coat because that was my secret when I had to give lots of presentations and talks. I would use this to help me last longer. See if it's cold enough yet. Hell yeah. Throat coat with honey. Okay, so basically saying this is something that we've seen. He's going to show us the reasons why he believes this, why it's being seen, but he doesn't know why it's happening. So that's, he's saying, like, we know this happens, we don't know why it happens, we need to investigate and explore why this is happening. Introduction. A remarkable feature of infection identified early in the pandemic was a relative lymphopenia in patients shown to correlate with poorer outcomes. Whether this was due to direct viral infection, activation-induced cell death, or migration to the periphery remains unknown. Severe COVID-19 is associated with a significant lymphocyte hyperactivation, organ infiltration, and tissue damage, suggesting widespread and perhaps deleterious immune activity.
T cell differentiation and collapse can be facilitated by the canonical death receptor CD95, and interestingly, Alesse et al. Described the increased expression of CD95 and PD1 on the T lymphocytes of COVID-19 patients and suggest it could predispose T cells to apoptosis and exhaustion. That's going to be a grain. That's a fun fact. So what that is saying is that this author right here has a study that can be referenced in source 5 that describes that increased expression of this CD95 and PD1 results in either the death of these T cells or causing them to get exhausted because they have to keep producing numbers and they keep getting destroyed by these natural processes that are being upregulated. So here we explore the implications of targeting lymphocyte death and differentiation on COVID via the Fas AKT, and we propose that CD95 may not only serve as a functional marker for apoptosis, but also a means of exuberant differentiation culminating in cytotoxic function, and this expression may represent a therapeutic point of intervention. So that's interesting. So basically, what this is implying is that being able to downregulate the expression of this Fas-Act pathway to downregulate the CD95 would make it so that your T cells are not being killed off by this process, this natural process in your body, and or they won't be exhausted. This is a new paper. Wow, they were seeing this already back in 2020. Yeah, this is a 2020 paper from December, so the end of the first full year of the pandemic is when it was published, entering the second year. So yeah, like they were seeing this way back then. Christina turned me on to this author, so I've just been going through some of his hits in terms of COVID. Oh, that's weird, just jumping straight to the discussion from the abstract, the introduction. Okay. Guess this is going to be like a lit review paper then. Anywho, so alternative hypothesis to the cytokine storm needed. So the reason why like everyone just uses the cytokine storm is that it's basically a blanket phrase for like, and then bad stuff happens, ... Because we don't fully understand the cytokine storm. We just know it's something that happens and it's just a bunch of hand waving essentially. So that's why I personally have been saying like, yeah, they just say the cytokine storm, whatever. But like this is also just saying that as well. So this author is personal hero. So the immune dysfunction in COVID has been so far enigmatic. At first, the focus was on elevation of cytokine characteristics of the innate immune compartment, a cytokine storm associated with severe COVID, including the upregulation of these factors that are associated with the cytokine storm, quote unquote. However, meta-analysis showed that interleukin 8 and interleukin 10 were substantially lower in COVID-19 as compared to conditions like cytokine release syndrome, acute respiratory distress syndrome, ARDS, and sepsis. So they're saying that other stuff is happening, not just the cytokine storm. Drink my tea. So the authors suggest the attribution of a cytokine. The authors suggest the attribution of a cytokine storm to COVID-19 pathogenesis was questionable. Oh, I love you, author. In a randomized trial, interleukin 6 blocking therapy was unfortunately noted to be of little therapeutic benefit in hospitalized patients. So not only is like this like big hand wavy thing that people are saying like probably not the case or probably not the full story, when you try to disrupt this pathway by blocking interleukin 6, which is part of that pathway for the cytokine storm, it doesn't do anything. So based on the findings from the people that did the study, Leisman et al., call for alternative hypothetical mechanisms explaining the level of organ damage and immune pathology. One consistency they note, however, is the preponderance of lymphopenia in cases of severe COVID, which is not good. And then lymphopenia is a disorder in which your blood cells don't have, or your blood doesn't have enough white blood cells. It doesn't have enough lymphocytes. Yeah, it does. We do have treatments for treatments. We are able to disrupt the cytokine storm pathway using treatments like the interleukin 6 inhibitor, and it works for some things. COVID just isn't one of them, from what this is telling us. So then the next thing, dissecting the possible T-cell migration, quote-unquote exhaustion, and end organ damage in COVID-19. A key question is whether the lymphopenia is a mere marker of worsening disease or is a mechanistic component where intervention could influence outcomes. So it could be that it's basically the chicken before the egg question, like, is COVID directly causing this, or is this an outcome from the ultimate consequences of COVID? So a secondary outcome measure that you can just be like, use as like a diagnostic scale, is that basically what that's saying. So Diao et al. And Wang note decreases in CD4 and CD8 T cells, and Wang et al. Show in a multivariate analysis that post-treatment decreases in CD8 T cells, B cells, and an increased CD4 CD8 ratio were independent predictors of poor outcomes. Another study by Modebacher et al. Described a causal relationship of the presence of naive T cell and claimed that in acute and convalescent cases of COVID-19 disease, severity was associated with a lack of. So yeah, that's going to be a big thing that I'm going to be looking at in a future point. Is that COVID kind of like knocks out these naive T cells that get differentiated and focused and specific. That's a big problem. That's makes it so that when you hear people saying, "Oh yeah, COVID makes it so that it's harder to fight off future infections," this is what they're talking about. Is this attack of the naive T cells? Because those naive T cells are needed to be differentiated specifically to future diseases that you are infected with, future pathogens, as well as for previous infections, the memory immunity. And when you don't have those, you can't send off the fighters, specific fighters. You just have a vague response that doesn't work as effectively as it could have. So Diao et al. Also noted elevated PD-1 and TIM3 expression on CD8 T cells in recovering patients, proposed the cells may be exhausted in the later stages of the disease, with CD4 cells showing elevated PD-1 expression and worsening disease. So basically saying that we're seeing things that could be considered exhaustion of this, the T cells, the CD4 T cells, and that these things seem to be markers that can be correlated with the exhaustion. So this is something that they could use to sort of track like how exhausted a person's immune system is. And then Zheng et al. Noticed a kinetic, where the total number of natural killer cells and CD8 T cells would decrease with worsening disease and upregulate the marker of exhaustion, NKG2A. Gonna do that so I can look at those in the future. There we go. But they claim with successful treatment with lopinavir, ritonavir, the counts would then increase, and then NKG2A expression would decrease during the convalescent period. Zhang et al. Did not find lymphopenia in their cohort. However, they noted that a non-exhausted subgroup of T cells were significantly reduced in percentage of patients with severe COVID compared to mild and moderate. I wonder if blocking that. Oh, I already read that one. Westmeyer et al. Sought to characterize the proteins that cause cytotoxicity and possible immunopathological organ damage, and they found in young patients CD8 T cells activated ex vivo following convalescent period produced granzymes. That's one word. A, B, and perforin at greater levels than healthy donors despite expressing PD-1, suggesting that exhaustion was not functional despite PD-1 expression. Highlight that. However, the CD8 T cells of the elderly group did not upregulate the cytotoxic markers as the younger group did, indicating age-related exhaustion. So what this is saying is that young people are more likely to have these immune effects than older people. And in their younger group, this is ages 29 to 79. So it's like, how old is this older group? But anyways, so they conclude that PD-1 expression CD8 cells should not be misclassified as exhausted. However, they state that PD-1 therapy may improve virus control, presumably in the elderly group, but may also exaggerate the immunopathology in the lungs and other organs. We agree with this therapy in regard to aged patients, but also propose that cytotoxic function may be overexuberant in younger patients, which is what my takeaway was, and that withholding differentiation may to an extent temper these expressions. Because of the possibility raised testing T cell modulators in preclinical animal models is advised. So yeah, so that's basically what I said, and then saying we need to test this out in animal studies. And then Wayland, I think it's probably like that, Wayland et al. Recapitulate the findings of Diao et al. And reports that STIM3, an exhaustion marker associated with chronic infections, including HIV hepatitis and pulmonary tuberculosis, had a rise in expression in severe ICU patients, which correlated with the measured degree of pulmonary infiltration and the cardiac marker NT-proBNP. So that's never something you want to see when, like, even back in 2020, COVID's being correlated with significant immune diseases like HIV, hepatitis, and tuberculosis. It's being grouped with those. And then Wayland et al. Hypothesized that T cells are traveling to these organs and are responsible for their harm, but temporarily upregulate STIM3 as a mechanism to prevent persistent and overshooting T cell activation, which could harm the host. They still, however, claim their findings suggest that T cell activation and exhaustion play a role in COVID-19 and posit T cell targeted treatment options may be of interest. So Wayland is believing that T cells actually are causing a lot of the organ damage and the organ harm that we're seeing, but recognizes that having them die off and become exhausted is a bad thing. So he's saying that it's a delicate balance, that you have to balance the potential organ harm that the T cells are going to cause with the decimation of your existing naive T cell population. So he's just saying, like, it's a two-edged sword. And then Varshetta et al. Report an increase in TIM3 and CD69 expression in CD8 T cells, And note, the extent of CD8 T cell lymphopenia was significantly greater in patients that succumbed to COVID. They described this as a hyperactivated, exhausted state, and observed that during recovery, TIM3 and CD69 expression on T cells fell, and CD8 lymphocyte count rose. They offer TIM3, PD1, and NKG2A as druggable molecules that may unleash antiviral activity. So again, multiple people are coming to the same conclusions, which show that these are likely good biomarkers to target to disrupt the activity so that you don't have this T cell death that's occurring. So in an autopsy series, Nienhold et al. Described two immunopathological reaction patterns. The first is characterized by lung infiltration of CD8 PD1 T cells that they speculate are causing diffuse alveolar damage, but better viral control, and they question whether PD1 positivity denotes exhaustion, but no conclusions are drawn. The other immunopathological pattern is characterized by significantly higher CD4 T cell lung infiltrates and a higher viral load. They conclude this suggests CD8 T cells indeed contribute to viral clearance, but may exert a degree of end organ damage. So again, they're saying that it's a dual-edged sword. That let me just highlight that. That it's a dual-edged sword. That if you upregulate these T cells, or if you don't. If you disrupt this PD1 activity and you have a high number of T cells, they can contribute to organ damage, in this case, diffuse alveolar damage within the lungs. But that allows you to control the virus better and have better viral clearance. However, if you don't have this response, then you're going to have higher viral loads and you're going to have a harder time clearing the virus, and then you can allow the COVID to cause more local issues and damage and have a worse disease outcome. So it's like, how do you balance these two things? And then Shrink et al. Found either one of two types of T cell infiltration in all autopsies, a CD8 infiltrate causing diffuse alveolar damage, or a CD4 interstitial infiltrate with exudative diffuse alveolar damage and bronchopneumonia. So yeah, so that's basically damned if you do, damned if you don't. It's a good example. I'm going to highlight that and make it green. Too many licenses to kill. So that's the damned if you do, damned if you don't. Oh my god, this guy's got a sense of humor. I'd love to talk to him. So multi-organ tissue damage is present in severe cases of COVID and multi-system inflammatory syndrome in children, the MIS-C, possibly contributed to by T cells activated by a super antigenic-like insert. That's something that he talks about in the other papers that we looked at yesterday. And after activation, such T cells may be capable of migration, that's interesting, to peripheral tissues following the differentiation and acquisition of cytotoxic ability conferred by effector differentiation. So, yeah, that's just saying that instead of having a specific T cell response, the superantigen is causing a generalized response, a mass generalized response where your T cells are being distributed everywhere instead of hyperlocally, which is resulting in this exhaustion because your body's like, fight everything everywhere all at once, is essentially what your body's saying. So Cheng et al. Argue that virtue of the superantigenic insert, infection would prime self-reactive T cells, combined with the apparent downregulation of FOXP3 in CD4, CD25 T cells, and their expression of FASL. I don't remember that being defined. FASL. Okay, we didn't get a... Gonna have to Google it. Fast ligand. Okay. Oop. So it's a cytotoxic protein expressed on activated T cells. The primary functions are attributed to FASL-mediated cytotoxicity, which is the ability of T cells to kill target cells in a calcium-independent manner, and the ability of T cells to kill themselves during AICD. Okay. This could bode poorly for organs and immune privileged sites. So the thing that happens, so like when the T cells are killing themselves, they're kind of releasing this local like cell toxins, so it can cause other issues when you have like a bunch of these just, I don't know how to say it, breaking down and releasing their contents. It can cause issues that way too. So this could bode poorly for organs and immune privileged sites. That's a fun thing to say. Immune privileged. I'm just gonna highlight that because I like that. Following COVID-19, even canonical immune privileged sites like the eye have inflammatory infiltrates, along with organs like the heart. Israelo et al. Observe hyperactivation of CD8 cells and their infiltration into the lungs in a murine model of COVID. Murine is that mouse. I think that's mouse. Yeah, relating to or affecting mice or rodents. Indeed, an increase in the frequency of effector cells has been shown in one else. T cell physiology correlates of COVID-19 disease severity. CD8 T cells in severe cases express increased levels of granzyme and perforin than in patients with mild disease. Whether this represents increased effector function or a marker for exhaustion in COVID-19 is unknown. So yeah, we don't know. We just see these things. We don't know why they're happening, at least in 2020. I don't know if we've learned since then. Since Calfoglu, Calfoglu, et al. Show even PD-1 was not inducing lymphocyte exhaustion. Taken with recent findings discussed previously, we propose testing the alternative hypothesis put forward by Westmeyer et al. The expression of granzyme and perforin may engender greater end organ damage by virtue of their function. All right, so now that we're actually saying that, let's look at what granzyme and perforin specifically are. Granzyme. It's an enzyme, I'm guessing for granulocytes. Granzymes are cell death-inducing enzymes stored in the cytotoxic granules of cytotoxic T lymphocytes and natural killer cells that are released during granule exocytosis when a specific virus infected or transformed target cell is marked for elimination. Perforin is a pore-forming protein, also known as cytoplasmic granule toxin. Granzyme is a family within the structure relating to serine proteases. Perforin forms a pore that disrupts the target cell membrane, including either the plasma membrane or the lysosol membrane. Once inside the target, it is granzymes that are the initiators of cell death. So when these granzymes are released, once it destroys itself, it can literally just cause issues with wherever they self-destruct. These insights and observations suggest exuberant activation in COVID-19 may facilitate the differentiation of T cells. Over exuberant acquisition of effector function may be targeted through CD95's non-apoptotic signal via AKT. So they're just saying that we might be able to mess around with it through this site. So I'll make that green. Something to follow up with. So the evidence of absence. Evidence of absence is not necessarily absence of evidence. That's something you'll hear a lot in science. So Zinzula describes the crucial role of the type 1 interferon response in COVID-19 in respect to the viral or F8 protein, when this protein, which downregulates the multi-histocompatibility complex, boom, is ablated with the frame shift. My brain just pulled that one out. Boom, boom, Ron, boom, boom. Or no, that's not from Ron. That's Boom Boom Nutriboom from 911. Not 911. Brooklyn 911. Brooklyn 911, I think. 99. So when this protein, which downregulates MHC1, is ablated with a frame shift mutation 382, patients experience mild illness. A study of patients with the mutation, Young et al. Find these patients exhibit higher levels of interferon gamma, interferon alpha, interleukin 2, interleukin 5, which they contextualize as associated with T cell activation. Okay, illustrating the importance of an early response. So they're saying that we can't really do downstream activation to disrupt this stuff. We have to do upstream activation, or upstream disruption, I guess is the way to phrase it, to prevent downstream activation. It's just targeting like where in the phase, like if you think of it as a linear thing, like a linear sequence of events, you have to target right towards the beginning versus at the end. 9-9, yes, thank you. 9-9. So Tan et al. Show early T cell responses were associated with rapid viral clearance and mild disease, suggesting an early interferon gamma producing CD4 T cell response may be implicated in viral control. So that's interesting. So without early control, COVID may accumulate and create pathogenesis through cytopathic and immune-mediated mechanisms. Habel et al. Describe an irreconcilable, there we go, amount of CD8 plus T cells, quoting this as bystander activation by some mechanism. T. They also observe in convalescence a paucity of circulating effectors subsets and describe it as either due to 1, limited clonal expansion and differentiation, or 2, T cell effectors are being driven to sites of virus-inducing pathology and to apoptosis. So they're talking about the bystander effect. They're saying that it's likely due to these two mechanisms. Either just like the virus is limiting the ability to differentiate these naive T cells, or it's just sending them out in droves without the differentiation. And then when it does that, they have this programmed cell death, which can cause a lot of that end-stage organ issues. In a transcriptome analysis, Zhang et al. Found that the CD8 naive T cell subset did not restore to the levels of healthy donors in convalescence. And that a subset of CD8 effectors expressing GNLY had highly cytotoxic function, became high and remained high even in convalescence. That's not good. So it's showing a sustained immune response, which results in that exhaustion over time. If you stay at very high levels of this response, this activation, your body can't do it forever. It'll get tired, and that's the immune exhaustion that we're talking about. And they're showing that this happens even after like the down phase of the viral clearance. That's the convalescence. So further, using gene set ontology, they found statistically significant stepwise increases in the programs for 1, apoptosis, and 2, migration in T cells from patients with COVID-19, which led them to conclude T cells in severe patients likely underwent migration and apoptosis. Save. Taken together with the proposed presentation, or the proposed presence of a superantigenic link asserted by Cheng et al., we propose that attenuation of the honest expression of multi-histocompatibility complex 1 by ORF8 may allow superantigenic accumulation to a point to when the adaptive compartment is finally presented antigen. There is an atypically massive viral protein in superantigenic burden in the pipeline, which may hyperstimulate, lead to AICD. All right, let's look it up. We've seen it more than once. It's important. AICD. Response. No. AICD cells. Activation-induced cell death. Okay, cool. I've never seen the acronym for that. I've only ever read activation-induced cell death of T cells. Activation-induced cell death. Cool. So in the pipeline, which may hyperstimulate and lead to activated immune cell death. It's weird when I don't have activation-induced cell death. Overexuberant differentiation, tissue migration, as per the alternative hypothesis put forth by Habel, and cytotoxic function. So indeed, De Biasi et al. Find production and release of cytokines they describe as similar to a polyclonal superantigen-driven T cell activation, and observed increased levels of interferon gamma in the plasma of COVID-19 patients. They also noted that the increased expression of CD57 on CD8 T cells of COVID-19 patients, which they claim denotes a susceptibility to activation-induced cell death and a lack of proliferative capacity. So that could be a biomarker. However, Focosi et al. Note there is preservation of cytokine secretion after stimulation of the CD57 lymphocytes. Furthermore, Chattopadhyay et al. Have noted CD8 T cells expressing high levels of perf were uniformly bright for CD57. Okay. Interesting, I guess. So with the findings by Balesi et al. Of increased CD95 expression, we believe there may be a contributing element of apoptosis to the lymphopenia observed in... Oh, right, there we go. I was like, so what are you saying? So, yeah. So, so with this increased CD95 expression, it's likely a contributing element for the apoptosis, which contributes to the lymphopenia, the decrease in those white blood cells in the blood observed in COVID-19, but it's a challenge to prove. As cells with which apoptose by this mechanism do not remain for functional readouts. So that's why they're saying evidence of absence, because evidence of absence is not the absence of evidence, which is, I said that at the beginning, I'll loop it back to now. So because we can't directly measure the death of these things, because when the cells die, they, which is apoptosis, they die, we can't measure them. We can't functionally measure them because there's no cell activity. And if there's no cell activity, there's nothing to measure. So we can't rule out the possibility of this mechanism, which is the absence of evidence, because we can't measure it, and the evidence of absence. So it's the evidence of absence is we're showing that this thing likely happens. We think because this, and this thing likely happens. But because this thing happens, we can't measure it. So just because you can't prove directly that something is happening, it doesn't mean that it's not happening, is the concept that I was trying to explain there. So the evidence of absence is not the absence of evidence, is the phrase. So feel free to use that. So, but this is a challenge to prove exogenously. I guess I'll just highlight that just because it completes the story. So exogenously, then outside the body usually, withholding differentiation may, 1, reduce the expression of the cytotoxic proteins like granzyme and perforin that Westmeyer et al. Theorized contribute to end organ damage. 2, maintain CD62L expression and other functional markers associated with less differentiation, which may keep T cells from peripheral migration. And 3, prevent CD94 mediated cell death, which has been shown predominantly to occur in differentiated effector memory lymphocytes rather than naive stem cell memory and central memory subsets of differentiation. So that's actually important to highlight. So the reason the body might do this, they're saying, is because it ultimately limits, or great, now you got me doubting myself. Yeah, external factors. So they're saying, all right, now I understand. For whatever reason, my brain tripped up there. But exogenous, that's typically something that you do outside of the body. So if you were to prevent the differentiation from happening, if you do this upstream mediation, you can have all these beneficial effects, is what it's saying there. So a quick drink of tea. So aberrant effector differentiation has been described in CD4 T cells in severe cases of COVID-19. Yep, we've read that sentence many times. Calfeoglu et al. Describe in aberrant the differentiated subset, CD4, CD25, FOXP3. T cells, they call hyperactivated T cells, which become multifaceted Th1, Th2 effector cells rather than TREGs due to the repressed expression of FOXP3. Those CD4 plus CD25 plus T cells vigorously proliferate, downregulate FOXP3, and express FASL in a dysfunctional differentiation pathway induced by COVID-19. The authors also state that the CD25 plus hyperactivated T cells also expressed PD1, but noted it was not able to control or suppress their function and hypothesized that CD80 may be suppressing PD1 function. All right, so that's all of that is to say that PD1 alone might not be the target. You might have to go up one level. So that target that is up one level is the CD80, which might be they might be the target for that's been suppressing the PD1 function. So we would like to bring this in sensitivity to exhaustion in context to the observations and assumptions of exhaustion and studies studied previously. Such sensitivity to PD1 in these aberrant cells represents exuberant function, and the FASL expression may represent a liability. For example, FASL expression on CD8 plus T cells is known to confer a paracrine T cell fratricidal liability in vivo. That's not good. So, blah, 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 blah. And then the important sentence. Having this FASL expression on the CD8 T cells confers fratricidal liability in vivo, so it kills surrounding tissue or damages surrounding tissue. And a paracrine T cell to T cell FAST signal was also shown to enhance differentiation of CD8 T cells by concurrently stimulated memory CD8 T cells in an effect that was migrated by a FASL blocking antibody. This paracrine effect of FASL also pushed naive CD8 T cells to express dramatically increased. All right, so then the two things. That and then so two extra things is that this paracrine T cell not only is like damaging surrounding cells, but it's sort of like force maturing the CD8 T cells, the naive CD8 T cells, and apparently the memory CD8 T cells. I don't understand why it would be doing that. But that's going to contribute to this immune exhaustion. It's like another phase. Like you have this sort of like friendly fire in your body, and then from this friendly fire, from the fratricide of the cells, it's forcing CD8 T cells to be dispersed, potentially to clean up the mess. I'm not really 100% sure. And then not only that, but it's upregulating those enzymes that can cause issues that we talked about earlier. So much like their CD8 plus counterparts, non-apoptotic signaling of FAST differentiates murine, that's mice, CD4 T cells as well. Cruz et al. Shows that LZ-FASL treatment during in vitro stimulation of CD4 plus cells enhances differentiation from naive to CD44, CD62L effector memory for wild-type CD4 T cells. Differentiation was induced in FAS. So yeah, they're showing the same thing. I still don't understand why the memory cells are being upregulated. Hopefully they'll explain it. Differentiation was induced in Akt-Fas palmitoylation deficient cells. So this is a specific cell line which are replete in non-apoptotic Fas signaling but have a palmitoylation defect which prevents the apoptotic signal of Fas and therefore the apoptosis, but not for CD4 LPR cells, which are completely deficient in Fas signaling. Additionally, non-apoptotic signaling of Fas has been shown to reduce the frequency of FOXP3, CD4, and Tregs in mice. LPR mice completely deficient in Fas signaling were crossed to express a version of Fas that was replete in non-apoptotic signaling, but that had the palmitoylation defect, had a decrease in Tregs from the higher frequency of that in LPR alone to a normal near wild-type frequency, which may suggest non-apoptotic Fas signaling in vivo may reduce the frequency of the expression. Furthermore, AKT signaling in human cells represses FOXC01, a key transcription factor that enables FOXP3 expression and function. CD4 T cells, like CD8s, have effector differentiation withheld during stimulation with an AKT inhibitor. Also, retain functional FOXC01 seems warranted to test whether FOXP3 expression can be maintained by inhibition of the Fas AKT pathway in the COVID disease state. So that was a bunch of word salad, but this is the thing. That's basically all you want to take away from it. Is that people need to look at the FOXP3 pathway. If you remember, there's a study that looked at the FOX gene. I've read that one. I already read that one, but it's waiting my red thing to make a video on. And unlike the, what was it called? Something with an H. HLA. Unlike the HLA study, which was absolutely terrible and I tore that apart, those authors should be ashamed. The FOXP3 one that I looked at actually had a lot of merit to it, and it ties in really nicely. It's correlating with a lot of the same signals that we're seeing, like in the thalamus and the amygdala and other areas that are correlated with our COVID disease states. So I do think that FOXP3 expression is highly involved in this. So that basically all this is saying from all that word salad I just read is that people need to look at this, and that this FAST-ACT pathway could be a way to prevent some of these issues. Man, this is a long one. Are we almost to the end? A couple more pages. We'll make it. Save. CD95 sensitivity following activation leading to differentiation. In parallel with lymphopenia in severe, my legs are itchy. In severe cases of COVID-19, the machinery responsible for T cell death and differentiation are enriched as well. Alessi et al. Showed CD95 was highly expressed on the T cells of COVID-19 patients, and Matthew et al. Identified CD95 as a marker of aberrant CD8 cells in an immunotype associated with severe COVID. So again, just reiterating what they told us before, both the expression of CD95 on T cells and the sensitivity of CD95 stimulation are rapidly inducible through T cell activation. Yep, I told us that. And Cheng et al. Argue T cells are activated by a superantigenic motif of the spike protein that is highly similar to staphylococcal enterotoxin B. And yep, that's a very interesting thing. Yeah, green's fine. Activated T cells are especially sensitive to the CD95-mediated differentiation signal. Interestingly, a non-apoptotic CD95 signal was shown to cause differentiation and effector function in activated CD3, CD28 stimulated murine and human cells in a dose-dependent manner with leucine zipper-tagged phospholigand. And this differential signal is carried through AKT. Interestingly, the death induced by tremorized CD95 ligand was shown to be predominantly limited to the terminally differentiated cells rather than the naive and central memory. Man, that sucks. So this at least in this experiment, when they were trying to target the pathway that they were just talking about above, it seemed that it was limited. It's only part of the story. It's only part of the potential solution, because it seems to only have a positive impact on the terminally differentiated cells that have already been, that are basically assigned to that cell death, the apoptosis. It didn't really do anything with the naive cells and the central memory cells. So 1 out of 3. It might be the answer for 1 out of 3. So furthermore, death and differentiation were withheld during in vitro stimulation and expansion of T cells by using an AKT inhibitor, even in the presence of Akt-Fas, revealing a dominant effect of AKT inhibition for the migration of CD95 signaling. Considering this mechanism of widespread activation, T cells not specific to COVID may differentiate, achieve expression of functional cytotoxic proteins, and die, possibly via a CD95 mediated component. Figure 1. Let's scroll down to figure 1. Okay, so yeah, basically what I just told you. And their picture's not that good, so I'm not going to explain it. So who will be the first to act? Sorry. Oh, God. I love when they throw puns in. Who will be the first to act? So I guess it's supposed to be pronounced ACT as opposed to AKT. ACT inhibition as a potential therapeutic for COVID-19 has been proposed in the past. Fagon et al. Described a transcriptomic profile in which AKT signaling was associated with disease progression, and Somanath discusses a similar rationale of modulating immune-mediated inflammation, that ACT inhibition is justified on the basis of an anti-inflammatory effect exerted by CD4 T cells that may differentiate into effector T cell regulatory cells in the acute respiratory distress syndrome, ARDS, in the lung. While we concur, we would like to supplement this argument further with discussion of the effect on the differentiation and acquisition of effector function and the inclusion of non-apoptotic CD95 upstream signaling. ACT inhibition has also been proposed on the basis of an antiviral effect. So basically it's just saying this inhibition can do an antiviral effect on COVID, and then it can also sort of prevent this CD95, which causes, what did it cause? It caused, I think, I can just look so that I don't say the wrong one. And the CD95 is associated with the apoptosis of those cells, the programmed cell death. However, it appears that in presenting stages of COVID, disease antiviral agents seem to have questionable therapeutic benefit, possibly due to the disease entering an immunopathologic stage of exuberant lymphocytic response. Sorbera et al. Claim COVID-19 or SARS-CoV-induced apoptosis via a capsase-dependent mechanism may suggest inhibition of the Fas-Fosl interaction may have efficacy in COVID, but the rationale describes differentiation. So finally, and again, the targeting of that CD95 seems to, is that in this one? No, that's CD80. Never mind. Sorbera et al. Claim COVID-induced apoptosis via a capsase-dependent mechanism may suggest inhibition of that interaction. Go to the rationale disregards differentiation. Already read that. Finally, in a CRISPR Cas9 lentiviral vector knockout of GM-CSF. Guessing that's in the cerebral spinal fluid. GM, don't know what that is. Gross motor cerebral spinal fluid. I don't know. In CIR T cells, Fas expression was significantly inhibited. That's good. Which the authors agree would reduce CAR T apoptosis. And GM-CSF inhibition trials are undergoing, considering 1, the role of the immune system may have in COVID pathogenesis, 2, the observation that FSL is upregulated, and 3, what? GM-CSF. Okay. That's why I was very confused. It was not that. So GM-CSF is granulocyte macrophage colony stimulating factor. It's a monomeric glycoprotein that functions as a cytokine. It is white blood cell growth factor. Okay, so it's the white blood cells. Getting a ton of text. Okay, so granulocyte macrophage colony stimulating factor that works on upregulation, the growth of white blood cells. Yeah. So now I can put it back in context because I was confused. So so they're looking at the inhibition. That's the prevention. Interesting. I'm not sure why they would want to prevent it. Did I miss something? Oh, okay. So inhibiting the growth of these white blood cells seems to be like another potential target, but I think that's going to have other implications, and that's what they're listing here. So the implications of like limiting the growth of white blood cells, like the lymphopenia that they talked about earlier, which is the reduction of white blood cells present. So you'd be artificially stopping the growth of those, and like we need those in our immune system to like help fight the COVID. But it could be a potential target. So it's saying that investigation is warranted and that there are ongoing studies back in 2020. I'll have to follow up with these to see, gonna write that down, to see what the result was. I'm guessing not promising because it's a trade-off there. GM CSF inhibition trials. To regulate FAS pathway. Okay, so physiological type 1 interferons required in, I hate this word, etological subset of COVID-19 disease. Etological I know I'm saying that wrong. Did I spell it wrong? AETIOLOGICIO. Okay, I'm not going to give a pronunciation, so I'm just going to go with my pronunciation. So, while we propose the attenuation of an exuberant effector differentiation may dampen end organ damage, there's a caveat to the general application of the proposed mechanism that requires nuance in the diagnosis meant for the patient with distinct etiologies. Lee and Shin discuss the heterogeny of type 1 interferon responses and attribute the cause of such discrepancies as due to timing of the observations, early versus late, and severity of disease, mild, moderate, severe. They propose a feed-forward mechanism found by Lee et al., where type 1 interferons break a tolerance induced by the tumor necrosis factor. Lee et al. Posit that an early interferon 1 response can control viral replication, but a delayed response can cause pathologic immune inflammation. Indeed, an interferon deficit can permit high levels of detectable virus in the blood, illustrating this heterogeneity. Lee and Shin said a trial which found administered interferon alpha had a protective effect if given early and a detrimental effect if given late. So it's very important for the timing of that. Which means it likely isn't going to be a good target drug because a lot of viruses evolve, its stages change, and then it could literally make people worse if they are mistaken of when they started the disease, et cetera, et cetera. So for that, furthermore, Bastard et al. Described individuals predisposed to severe COVID-19 with autoantibodies against type 1 interferons, representing about 10% of a cohort of severe patients. And Zhang et al. Identify inborn errors of interferons, including those ones in 3.5% of patients in a cohort with life-threatening COVID. We believe studying the role of CD95 in a murine model, mouse model of COVID without such inborn or acquired errors may not replicate the autoantibody or inborn errors of interferon seen in a subset of patients, but rather be more comparable to the pathological experience of a patient without such inborn defects in the interferon or autoantibody responses. We cannot comment on the T cell kinetics or differentiation states of such patients, or whether altering T cell differentiation would be a boon for such patients, as insufficient data exists. However, Zhang et al. Propose it would be helpful to identify such patients early or even before infection so that they may have their deficiencies supplemented with interferon when an efficacious therapy is found. So everyone's body's different. We say this all the time, but these people that are treated with these types of therapies would not have a beneficial effect with these therapies because they have errors. They have predisposed not functional interferons, so they have to sort of be supplemented with these. They have to have that fixed simultaneously while they're receiving the therapy, or else the therapy is not going to work for them. And then mitigating the T cell physiological consequences of COVID-19. CD4 and CD8 T cells post-COVID were on the whole less comprised of naive and memory subsets and survivors versus healthy donors. while the former had a lesser proportion of naive T cells on a background of lymphopenia. So people with COVID had less naive T cells because a lot of these got distributed throughout the body randomly to fight the superantigen. So they got depleted, and then not only that, they have low white blood cell counts, which is that passive immunity that exists in your body. So when taking this finding from Yang et al. Of a diminished proportion of naive CD4 and CD8 T cells post-COVID-19, along with the finding from Mortebacher et al. That naive CD8 T cells are associated with lesser disease severity, we must consider the consequences of reinfection if the pool of naive T cells significantly diminishes after infection. Outcomes are influenced by the presence of naive T cells. So again, that's saying that another consequence of being constantly and repeatedly reinfected with COVID over and over and over again is that it's going to have stacking consequences. That with each infection, you're going to be depleting more and more of this finite resource because we only have so many T cells. It's like a good correlate is oocytes, whatever, the eggs, women's eggs. You only have so many eggs, then you hit menopause. We only have so many naive T cells, and we need all of them for as long as possible. And with each COVID infection, you have less and less and less and less, and we don't know what's going to happen in the long term if this continues to be depleted with each subsequent infection. So in the scenario, it would be best to preserve lesser differentiated population of T cells by blocking CD94 mediated T cell death and differentiation in vivo in life, which is precedented in a murine human xenograft model of CAR-T adoptive immunotherapy. CAR-T cells transduced with a recombinant Fas receptor lacking an intracellular signaling domain were subsequently more capable of inducing durable tumor responses and showed increased in vivo persistence, presumably by virtue of their attenuated differentiation and death. Also blocking T cell effector acquisition in vitro during TCR simulation and expansion with a CD95 blocking antibody, or with an AKT1, AKT2, AKT3 or 8, 8 inhibitor has been shown to allow tumor-specific CD8 T cells to proliferate without differentiating. So this is just talking about a pathway. Thereby greatly increasing the numbers and withholding premature apoptosis. So using this type of therapy, you can hold on to the number of T cells without having them prematurely die from the COVID infection, from the results of this cascade within the COVID infection. Furthermore, on a cell-for-cell basis, T cells with their differentiation withheld by ACT inhibition were superior at eradicating established human and murine tumor after adoptive transfer in both a murine and murine model. So it seems like this is something we would want to do. A therapy would want to implement this ACT inhibition, AKT, because once the active infection is over, we'll still have these, which can help fight off the current, like the ends of the current infection, the viral persistent phase, as well as for future infections that aren't necessarily COVID. Xenograft models of adaptive T cell immunotherapy, ACT inhibition, also maintain a higher percentage of all those T cells after stimulation, and Fas signaling induced with blah, 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 blah. That's everything I just told you. So to the conclusion. So the role of an ACT-mediated CD95 signal as a causal factor rather than a marker in this aberrancy warrants exploration. So we want to look into this. This is interesting. There's enough evidence out there to say that this could be a potential therapeutic strategy. since CD95 could be implicated in the exuberant effector differentiation and death of T cells in severe COVID, and not just severe, but even like mild and moderate cases as well. It's just the most pronounced in these severe cases. Given the dual function of CD95 mediated differentiation and death may be advancing T cells to greater effector acquisition, fewer numbers, and immune dysregulation. So like those are the problems that are happening likely from this. And then this may be a pathological state yielding tissue damage. And then the result of this is tissue damage, like everywhere in your body. So whether CD95 mediated death and or differentiation is pathogenic can be tested in murine models of severe lethal COVID, like the K18 ACE2 mouse. So there's a human ACE2 receptor mouse model, so that's what they're referencing here. I'm guessing K18 is the specific like name for the mouse. Preclinical animal models of severe COVID-19 that recapitulate a type 1 interferon competent and lymphopenic experience may be useful for the investigation of a strategy that seeks to preserve. So then having an animal model that isn't like part of that population that has interferon issues, and kind of has an ability to show this lymphopenic state, this reduced white blood cell state after a COVID infection would be like the ideal, because then you can have your control and show like, hey, look, this is our mouse that has a COVID infection that produced very low white blood cell count, just like we see in humans. We treated this mouse with this drug. We found that after the COVID infection, when we had this treatment in that mouse, that these things happened, and that we retained the naive T cell population, that we didn't have this peripheral programmed cell death, that we didn't have this diffuse organ damage from this diffuse response. So that's essentially what they're saying. They're saying like, look at this. This would be like the best model. The likely, if we can get that to work with this type of mouse, the human ACE2 receptor mouse model, and figure out a specific strain or breed a certain strain that can show these things, or even if it's possible to show it in those mice, then that would be like the ideal animal subject model to prove this or disprove it. And that's it. That's the work from 2020. Save. Cool. Well, I am going to pop off. Thanks for swinging by. This was a dense one, but I thought I learned a lot, and there's definitely stuff I want to follow up with in future papers. Cool. Have a good one. Yeah, no problem.